In this lesson, we'll talk about working with strings in iOS apps. You'll find a completed version of this project in your working files directory. Now, strings are one of the most important and frequently used data types in any programming language, and Objective-C is certainly no different. In ANSI, strings are simple null-terminated character arrays and provide no functionality on their own. Instead, they're manipulated using the functions found in the C standard library. Now, luckily for us, in Objective-C, strings are full-fledged objects, so in addition to storing the character data, they also provide a significant amount of functionality. And this functionality is provided by the Foundation Framework's NSString class. Now, strings are so commonly used that Objective-C actually provides us with an object literal for creating them. And we've actually seen quite a few examples of this already in the code that we've written. Anytime the compiler encounters an @ symbol followed by a quoted string, it knows to create an NSString for us. In fact, this is really equivalent to me manually allocating a string like this. But of course, the latter form is certainly more succinct and much more readable, so this is what we typically tend to do. Now, you may be wondering, since we have this object literal syntax, why would we ever bother explicitly creating a string? Well, there are a number of reasons, but one of the more common ones would be when we're working with what are called format strings. A static string definition is fine when we know the value at compile time, but very often we need to build strings based on some dynamic data. For instance, we want to show a message to a user based on some input they just entered into a text field. In this case, we would need to dynamically build a string, and we can use format strings to help us in this case. Format strings allow us to define placeholder characters in a string, and then dynamically replace them with a value at runtime. We've actually seen a number of examples of using format strings through our use of the nslog function. Now, in this particular case, I'm using this NSString string with format method, and I'm passing it a format string. So I've got %@ space %@. These two %@s are just placeholders for an Objective-C string reference that I'll be passing in. So in this case, I'm passing in first name for the first specifier and last name for the second specifier. So if I run this, I'll see I have this nicely formatted string. Now, this %@ specifier you'll use quite frequently. Anytime you want to print a string version of an Objective-C object, you'll use this specifier. But there are actually quite a few you can use. If you go up to the Help menu and select Xcode Help and type in the words format specifier and highlight any one of these, you'll see a full list of all of the different format specifiers that are supported. So there are specifiers for simple integers, floating points, C strings. A wide variety of them are available. Now, a very common thing we do with strings is concatenate their values. So if we want to add one string to another, we can use these various concatenation methods. So I've defined 3 different strings, and I'm simply logging the first one. And then the second log statement, I want to take the first string and append B onto it. So I'll do so by using the string by appending string method. Now this will concatenate these two values together and return a new NSString instance to us. And because this method returns a new NSString, we can actually chain these values together. So if I wanted to take A and B, concatenate those together, and then take that result and then concatenate C onto the end, I can chain these methods like I'm doing here. So if I run this, I'll have these all nicely concatenated together. Another common thing that we do is work with substrings. So oftentimes we want to read just various substrings from within a larger string. So here I've got a string called USA with the value United States of America. And if I wanted to read the word United from this string, I can use the substring toIndex method. So this will start at the beginning, which is a 0-based index. So we just count up 6 characters, 0, 1, 2, 3, 4, 5, 6, and grab those first 6 characters off of there and then print that to the console. If I wanted to read the word America, I can use the substring from index. So this will say go up to the 17th index and then read to the end of the string. So I'll run this and we can see the result. United and America printing out to the console. But what about if I wanted to read the word states? Well, I have to take a slightly different approach for reading strings from within the middle of a string. I'll use this structure called NSRange. And a range is just a simple C data structure. Let me just go look at the definition of this. So it's a structure that contains two elements. It has a location, which is the index location in the string, and then the length, so whatever the length of the string is that we're trying to retrieve. So I can get a range by asking the string for the range of a particular substring. So I'll ask for the range of states. And then to print this out to the console, I can use the string method's substring with range and pass in that range to it. And I'll run that. And now I can see that I have the word states. So it's a good idea to get familiar with these various substring methods, as you'll find frequent use for them. Now we can also easily change the case of our string. So I've got a string called message with this nicely cased string. If I wanted to convert all of the characters to lowercase, I can use this lowercase string method. Or if I wanted to convert to all uppercase, I can use this uppercase string method. Just run that. And we can see the results of those calls. So these can be convenient methods if we're trying to normalize the case across a variety of strings. And the last thing I want to talk about is testing equality. This is a very important topic when we're working with strings. Now, you might be inclined initially to perform a test like this. Let me change this to the appropriate type. And say the Beatles equals to Led Zeppelin. But of course, this really isn't the test that we want to perform here. What we're testing when we make a comparison like this, we're really testing the identity, not the equality. So we're saying, is this pointer reference the same as this pointer reference? And when it comes to working with strings, that's usually not particularly important. Generally, we're more concerned that two different string references contain the same characters. So really what we want to do in this case is to use this is equal to string method instead. So I'll say the Beatles is equal to string Led Zeppelin, and then based on the result of this expression, it will return a string yes or no. So I'll log that to the console, and I'll define this format string, our placeholder and placeholder equal. So I'll pass in the Beatles, Led Zeppelin, and then the result. So I'll go ahead and run that. So as we'd expect, those are not equal. But if I were to change this, and I typed in the Beatles, and let me just copy that, and I'll run this again. Are the Beatles and the Beatles equal? And that, of course, equates to yes. The NSString API is large and provides a lot of different functionality. So what we've covered here is really just a small subset of the things you'll do with NSString, but these are things you'll do quite frequently, so it's a good idea to get familiar with these methods. But certainly take a look at the API documentation for NSString, and we'll continue to use this throughout the course, so I'll show you some additional examples as we go along.